Okay, real gases, liquids, and solids. So let's review the ideal gas law. You remembered? The behavior of gases can be described by this equation right here, PV equals nRT. What's P? Pressure of the gas. V is the volume of the gas. T is temperature of the gas in Kelvin. N is number of moles of gas particles, and R is a constant. Okay, and that's the same constant for all gases. Well, that equation actually has limited validity. Okay, and the validity of that equation is this: it's true for all gases at very low pressure. So when pressure approaches zero, that equation holds for all gases. Okay, and so what will be the value of PV over nRT when P approaches zero? Well, if PV is equal to nRT, if you divide PV by nRT, that's going to be equal to 1, right? So we say a gas is behaving ideally if it obeys PV equals nRT, or you can say if PV over nRT is equal to 1. Now, typically, you'll be in error. If you use this equation, you'll be in error by about 1% at ordinary conditions. Okay, at STP, for example, room temp or close to room temperature, 1 atmosphere pressure. So it's a pretty good equation to use under ordinary conditions. But, like I said, that equation is not really true under all conditions. It tends to fail when you get to higher pressures. Okay? So, and it also tends to fail when you are at very, very low temperatures. Because what happens eventually at very low temperatures? What's the prediction of the ideal gas law versus temperature? Volume decreases and eventually it goes to zero, right? So it remains a gas, no matter how cold you make your gas, okay, it will stay as if it's behaving ideal, it's going to remain a gas, and its volume will just disappear when you get to absolute zero. Well, what happens to a gas when you actually cool it? It turns into a liquid. Okay, so it ultimately at low temperature starts to fail. Now, so how can we tell if a gas is behaving ideally? Like I said earlier, what you do is you measure P, V, T, and N. And how can you tell if it's behaving ideally? You calculate Z. Z is called the compression factor or compressibility factor. So it's equal to PV divided by nRT. And so if the gas is behaving ideally, PV is equal to nRT. So PV divided by nRT will be equal to 1. So the compression factor of a gas is equal to 1 if it's behaving ideally. Okay? Otherwise, if you see deviations from 1, okay, then you're going to get a value of Z that's significantly less than 1 or greater than 1. So that's how you can tell.